Okay, in this section we solve system of equation in two variables. So these are the three objectives: solve system of equation using graphing method, solve using substitution and elimination method, and finally solve some applied problem. So let's say you have system of equation in two variables. There might be more than two equations. That's why it's called system of equation. Two or more equation. For example, this one, as you can see here, there are two equation and there are two variables. Our job is to find the value of x and y if that x and y satisfy both of the equation. So this is a system of two linear equation in two variable. For example, for this problem, the solution is 2 and -3, because when you put x equal to 2 in the first equation and -3 in first equation, that will give you the true statement. 2 minus -3 is actually 5. And similarly, if you put 2 here, which is 2 times 2 is 4, and then y is -3, 4 minus 3 is 1. So this is the solution for both equation. That's why it's called solution for the system of this equation. So there are different ways to find the solution. One of the ways is graphing method, meaning you try to plot the graph of both equation, and then wherever those two lines intersect, that would be the solution. For example, for these two equation, if we plot the graph, these are the two graph and then they intersect at 2 comma -3. That's why this is the solution. So if you can find one solution, at least one solution, then that system is called consistent. If the system has no solution, then that system is called inconsistent. Sometime you might have one solution, or you might have infinite solution, or you might have no solution. Okay, if a system of two linear equation in two variable has an infinite solution, the equation are dependent, meaning they are same equation. Otherwise they are independent. So these are the three situations. If we plot the graph, you might find one solution like this, you might find no solution like this, because these two lines, they are never going to intersect because they are parallel. And here you just see one line, but this is actually, you can say two identical lines, the same line, and they are overlapping each other. So every single point is the solution. So that's why there are infinite solutions. So you have three situations: one solution, to no solution, or infinite solution. Okay, so let's try to do one example. Let's say this is the problem. Okay, so let's say this is the problem. We try to solve this system of equation by using the graphing method. Our first job is to plot the graph of the first line. So for that, you need to find out the points on those lines. So how do you find the points? You can find 2 points on one line. So let me just go here and then find out the 2 points, because the first equation, as you can see here, this is x minus y equal -4. So that's the first line. So how do you find the points? Just make a table. Just choose the value of x. Let's say x equal to 0. If you put 0 here, what happens to the y? Y would be y equal -4, so y would be +4. This is one of the point on that line. What about another point? Choose y equals 0. You're allowed to pick for one of the variable, but you need to use this formula for finding the another one. I'm picking y equal to 0. That gives me x equal -4. So these are the 2 points, 0 comma 4 and -4 comma 0. I'm going to plot those 2 points here by using this line tool. 0 comma 4 is here, okay, and -4 comma 0 comma 4, and then if y is 0, then x equal to -4, so -4 comma 0. This is another one. As you can see here, if I click here, you will be able to see the point here. So that's the first line. I have to do the same thing for the second line. I need to find the points for the second line, and then I'm going to use the same trick. X plus y equal 14. So I need 2 points such that the value of x and y satisfy this equation. Let's say x equal to 0. then y would be 14. If y is 0, x would be 14. So 0, 14, and then 14, 0 are the 2 points. 0, 14, so I'm going to click this line tool. 0, 14, somewhere here, 12, 13, 14. Yeah, as you can see, if you don't see, you will be able to see the points on the top right. 0, 14, and 14, 0. 14, 0 is 14, negative 1, 14, 0. Okay, so that's the solution. From here, if you look at the graph, wherever these graphs, these two lines are intersecting, that is the solution. If you look at here, as you can see, the point is 5 comma, what is that, 9, 5 comma 9. Yes, it's a 5 comma 9. This is 5 comma 9. So the solution is 5 comma 9. This is the right graph, and then solution is there is only one solution, and you need to use parentheses 5 comma 9. Okay, that is the point where these two lines are intersecting. So that is solution for this system of equation using the graphing method. Okay, so there is another way to solve the system of equations. Sometimes plotting the graph could be very time consuming, so we use substitution method. Substitution method is a technique that gives accurate result when solving system of equations. It is most often used when a variable is alone on one side of an equation, or when it is easy to solve for one variable. So what do we do? Based on the two equations, we take one of the equation, and then let me just insert one blank page here. So let's see. Let me go use this one. Solve this system of equations using the substitution method. So I'm going to pick one of the equation which is easy to make one variable on one side. So I'm going to pick the first one. So as you can see here, the first one is easy. X minus y equal 7. I can solve for x by adding y both sides. That gives me x equals 7 plus y. I'm going to substitute this value of x in the second equation. So if you go to the second equation, which is 6x plus 4y equal negative 48, I'm going to put x equal to 7 plus 4y. By doing that, I can change the equation in two variable into the equation in one variable, in this case variable y. So distribute 6. 6 times 7 is 42. 6y plus 4y equal 48. So subtract 42, and then 6y plus 4y is 10y equal 6. So y is 6 over 10. If you simplify this, this is 3 over 5. So that is the value for the y. How do you find the x? You use this one, and you put y equal 3 over 5, and then add. To add the fraction with the integer, just make the same denominator by multiplying the top one and bottom one by 5. That would be 35 over 5 plus 3 over 5. So now, because both of them have the same denominator, you can just say 1 denominator 5, and on the top, that's 35 plus 3 is 38. So the value of x is 38 over 5. And what is the value of y? It's a 3 over 5. So the answer for this question is x equal 38 over 5 and y equal 33 over 5. 38 over 5, 38 over 5, and y equal to 3 over 5. And that is the solution. Okay, 3 over 5. 3 over 5. What happened? I don't know. Maybe I did not type it properly. Let me go back here. X equal 38 over 5 and y equal to 3 over 5. 38 minus 3 is 38 and 4, 12. That's supposed to be negative. Why I did not get negative? Oh, I made a mistake here. Do you see? There's supposed to be negative, but somehow I missed that negative here. So because of that, I did wrong calculation here. So I'm going to fix it by erasing all the work. So my work was wrong. So 6 times 7y plus 7 plus y, 4y equal negative 48, not positive 48. So distribute 6, 42 plus 6y plus 4y equal negative 48, and this is 10. If you subtract 42, that will be 10y equal that is negative 90. So if you divide both sides by 10, that would be y equal negative 9, and I'm going to use this x equal 7 minus 9, which is negative 2. So negative 2 and negative 9 supposed to be the answer. I did not get it right when I missed that negative sign. Negative 2 comma negative 9, that is the answer for this using substitution method. Nice work. So the next method is called elimination method. Sometimes substituting could be not easy. So what we do is we try to eliminate one of the variable from two equations by adding the two equations. If the coefficient of the variable are opposites, that variable can be eliminated by simply adding the original equation. If the coefficients are not opposite, it is necessary to multiply one or both equation by suitable constant before we add. So we need to do a little bit of work if the coefficients are not opposite at the beginning. So I'm going to show you one example here. Elimination method means our job is to eliminate one of the variable. So let me go and find out substitution. Okay, elimination. Look at here, this is the system of equation. So if we check the coefficient of the variable, the coefficient of the x on the first equation is 2, and then the second equation is 3. The coefficient of y for the first one is negative 4, and then second for negative 6. So they are not opposite. So we need to multiply this equation to make the opposite coefficient, and that we can do by multiplying the first one by negative 3 and then second one by positive 2. I'm looking at this coefficient and I'm just multiplying by these numbers, but for the first one by negative, because we would like to make it opposite. So if I multiply the first line by negative, this is what I'm going to get. Multiply by negative, so that will be negative 6x. Negative times negative is positive 12y, and negative 30. I'm multiplying the first equation by negative 3, and then second equation I'm going to multiply by 2. So 3 times 2 is 6, 6 times 2 is 12, and then 15 times 2 is 30. If I do that, as you can see here, this gives us 0 equal 0. That means this is actually the same equation. This is if you can see here, luckily we are dealing with the same equation. If you just divide by 2, it would be x minus 2y equal 5, and then you divide it by 3, it would be x minus 2y equal 5. So both of these equations are same equivalent equation. That's when you get 0 equals 0. That means the solution is infinite. So what do you say? There are infinite solution. And how do you find those infinite solution? So you keep x as x, and for finding the y, you take one of this and solve y in term of x. So what we do, let's copy the first one, 2x minus 4y equal 10. Keep in mind, both of these equations represent same line. So we need to present our answer in term of x comma y as a x. So in that way there will be infinite solution. So I need to bring this 2x to the other side. So negative 4y equal negative 2x positive 10. I just subtracted 2x, and then now I can just divide both sides by negative 4. By doing that, what happens is y is 2 and 4 cancel. It will give us half x minus 5 over 2. So the y value would be half of x and minus 5 over 2. Yeah, is that 5 over 2? Yes, minus 502. So by doing that, what happens is no matter what x you are going to pick, that will give you the solution here. So, and there are infinite x, that's why there are infinite solution. So that's the elimination process. The system, whenever you have infinite solution, the system is called consistent and the equation are dependent. Dependent means both of them are the same equation. Okay, so that's how we can solve system of equation using these three different process. Based on your situation or problem, you might have to use one of them. So we can use this technique to solve some real life application problem. I'm trying to find one. Okay, let's say this one. A few years ago, a total of 2,677,000 people lived in the metropolitan areas of Las Vegas. So that's a total population. Nevada and Sacramento, California. Sacramento had 281,000 more residents than Las Vegas. What was the population of each metropolitan area? Okay, so there are two metropolitan area. One is Las Vegas, another one is Sacramento. Let's assume that the population in one of the area is X and another area is Y. We have to always introduce the variable. So in this case, let's say X is population of population in Las Vegas, and then Y is population in Sacramento, California. So X plus Y is 2,677. That's what it's given. A few years ago, a total of 2,677,000 people lived in the both metropolitan area. So when you add them, it's supposed to be 2,677,000. Okay, 2677,000. And then Sacramento had 281,000 more residents. So Y is 281 more than X. 281,000 more than X. So Y equal X plus 281. So whenever this is a situation, we can use substitution method here. We can go back to the equation 1. We can put Y equal this value. So I'm going to go here and then I'm going to replace Y by X plus 281 equal 2677, and then X plus X is 2X. Subtract 281 from 2677. So 2677 minus 281. If you subtract, that is 2396,000. 2396. So what is the value of X? Just divide both sides by 2. So X is 1198,000. This is the 1000, okay, which is the population in Las Vegas. And then what is Y? Y can be found using this relation. Y is 1198 plus 281. So that is 98 plus 281. That is 1479. 1479. So what are the population in those two metropolitan area? One is 1198. The population of Sacramento area was, so this is the population for Sacramento area, which is 1,479,000. 1,479,000. And population of Las Vegas, it's 1198,000. 1198,000. So keep in mind, to solve this type of real life application problem, you have to introduce the variable for unknown things. Okay, so that's all for this section.